Hey, glad to see you. Glad to see Ton Badal from Synthesized. My name is Seva. I'm from Synthesized as well. And we're gonna start the very interesting topic. I'm very, very keen of such topics, honestly, since we are working together. But honestly, in reality, I really keen of test automation and testing things, even in data. Uh, in data area, it's really hard to get things done from the testing perspective. That's why we have Ton here, who will bring some light how we can do properly test automation or preparing the data, or get some test coverage done. And yeah, here we are. Ton, nice to see you here.
Hey Seba, hi. Thanks to having me. Thanks for having me here. Yeah, this is. I hopefully it's going to be an interesting talk because I come from a more machine learning background more than testing, and it's interesting because we're putting together the two worlds that usually are quite separate. So yeah, it's hopefully it's going to be interesting one.
Yeah, by the way, how did you come to this? Like, how did you come to dealing with all this sort of the things, like dealing with the data, dealing with the quality of data, even?
Yeah, as I was saying, my background is a lot about machine learning and data science, so it's more scientific than engineering. But with the years, we started seeing this problem in engineering about the data quality and about data analysis, about understanding the data, but putting that into more the engineering side of things. And yeah, in synthesized, we're trying to do this, and yeah, really exciting to put these different worlds together.
Oh yeah, oh yeah, yeah. Totally agree with you here. By the way, folks, I remind you that we have a chat in Telegram where you can drop some questions if you have such. During the talk, don't hesitate to do so. And by the end of the talk, I will ask these questions to Ton, and we will discuss some of those. If there will be a lot of questions, you will be able to talk with Ton after the talk in the discussion. So it's also a nice opportunity to talk and discuss data coverage, data generation, and things like that, which are yeah, really important for me, and I hope for you as well. That's why we are here.
Yeah. Yeah, thanks. And preferably in English. My Russian is a little bit not good yet. So
Yeah,
but
yeah.
yeah.
By the way,
Otherwise,
yeah, if you're not that good at English, yeah, don't hesitate to ask question in Russian in Telegram. I will translate them, so that's not a
great.
big problem. Yeah,
Great.
uh,
Thanks,
yeah.
Evan.
I think we can start the talk. Ton, are you ready?
I'm
Hope
ready.
you're
Yeah, let's get started. Yeah.
all right.
Okay. All right. So yeah, I'm gonna talk about the test data coverage, about optimizing data for testing, specifically for functional testing. But you're gonna see that the concepts that I'm gonna talk about, they are applicable to other fields, not just functional testing, other types of testing, and even other types of analysis that you can do to data. Okay, so let's get started. I already mentioned a little bit of myself, but to get a little bit deeper, I'm Tan Badal. I work as a machine learning engineer at Synthesized. I've been in this company for about 2 years, about 2 years, yeah. And what is Synthesized? Synthesized is a data ops platform that enables data collaboration by removing problems related to data, such as getting access to data, or having data that doesn't have enough quality, or also collaborating with data projects. Which those are three points that are usually quite problematic and make data collaboration quite difficult. In this talk, we're gonna talk about access and quality mainly, as I'm gonna see later, and a little bit about my past. I studied engineering in my undergrad in Barcelona. That's where I'm from. And then I went to the University of Edinburgh, where I studied my master's in artificial intelligence and machine learning. I learned the theoretical fundamentals of machine learning and AI. It was a really nice experience. That's my first introduction to the data world. Then I worked as a data scientist in a challenger bank in the UK, in London, for a couple of years, where I was participating in the decisioning process with related to data. and we were making decisions based on the data. So it involved all the data cycle from getting the data to and putting the decision into production. And so yeah, that's me. Here you have some contact details, my Twitter account, GitHub. Please feel free to contact me if there's anything that you want to ask me. All right, let's get into the talk. Okay, I'm gonna structure this talk in three main buckets. First, I'm going to talk about the problem of data, of why it's difficult to get access to data and why this data is not that good sometimes. And then we're going to look into these 2 points. So we're going to look at different techniques for accessing data. And then once we get the data, we're going to talk about how to improve this data in order to get the full coverage for your testing. I'm gonna talk and I'm gonna compare different tools that are available out there. The list is not exhaustive, though. Obviously, there are thousands, well, maybe thousands, big to number. But yeah, I'm going to talk about some tools. We're going to compare some of them. But yeah, I just want to highlight that the list is not exhaustive. All right, let's get to the problem. So this is how an example of a data-centric application, how it would look. So obviously, the data is the core of the application. It's very important. It's the core thing for the whole application. And here you can see, okay, we have a data source. We have some data sources. It can be some application, some third-party data sources, some web applications. You gather all that data and you put that data through your ETL. Then that ETL obviously extracts, transforms, and loads the data into your data warehouse. And then that data is accessible by your test engineers, by your QA engineers, data scientists, etc., everyone who wants to access that data. All right, what is the problem with this infrastructure? What happens usually is that we get what we call a data silo. Okay, what is a data silo? Data silo is a collection of data that is held, in this case, in this data warehouse, but this could be some other infrastructure. It could be a data lake also. And the problem of this is that for some reasons, this data cannot be accessible or fully accessible by the engineers, by the data scientists, or by anyone who needs that data. So that's what a data silo means. What is the cause of a data silo? There are a few causes. One of them could be knowledge. So the data engineers here are the ones who are in charge of all this process, from getting the data source into the data warehouse and putting the data into its place. And the knowledge and understanding that you need to get the data, it may be quite difficult. It may be not trivial. So you would require a lot of training to get that data, which would make the data access quite complex. And a second reason that I want to mention that it's very important in order to get data access is privacy. So with GDPR, with HIPAA, there are a lot of laws that don't allow you to just directly get the data and use it and look at it, because it contains user information, it contains very private and sensitive information. So if you want to start a data project, you will have to go to compliance, you will have to follow all some measures that may, a data project that it could take 1 week to develop, it could take more than 3 or 6 months even, just to get access to that data. So that becomes data silo. It's against development because it's against agile methodology, and it's going to make things very, very slow. All right, so these are the 2 problems. These problems can be solved by different techniques. For example, we can think about infrastructures. We could think about data mesh. That is a new infrastructure that is emerging. I'm not going to focus on the infrastructure point. I'm going to focus on the data point, on how to get that data. All right, let's say you were able, by some techniques, to put your data into different environments. For example, you have some development environment, you have staging, you have test environment. So you have each environment has different data, etc. All right, you partly solve that problem. Now, how would you make sure that that data that you have is adequate for your purpose? So for example, for the testing environment, how would you make sure that the data that you have in there is fully it covers all the side cases, it optimizes the coverage, is big enough for your performance testing, How can you answer all that questions? By looking at the data. That's the second part of the talk that we're gonna, well, actually the third, counting this as the first one. So that's the final part. Okay, let's go for it. Let's look at the first part of the problem. So how do we get access to the data in a safe and in an agile way? First thing you need to do, this may be quite obvious for many of you, but the first thing you need to understand is why you need your data, how you're going to use it. You need to do this exercise with your team where you ask all these questions and you make sure, because at the end these questions are gonna matter and are gonna make you choose one situation or the other. So here there are some questions, some examples, like why do you need the data? How are you gonna use it? Is it like, for example, let's go for two different examples. Do you care about data quality? So are you gonna use your data for machine learning, data science, for some to build some business intelligence dashboards, for example? Maybe if that's your use case, you're going to care about very high data quality that is going to look and feel and even taste like original data. Statistical properties are very important, etc. Or maybe in the other hand, you care about scalability. So you want to do some performance testing or you want to do some integration testing. In those cases, your data will look quite differently because maybe the statistical properties are not that important, but you care a lot about the amount of data that you can get, and you care a lot about high level information and structure, referential integrity, this kind of concepts. So you can see here that depending a lot on why you want the data, you're gonna need the data to look in one way or another. All right. So let's look at different techniques of getting that data into your environment. So first case, the most simple and straightforward thing that you can do is get your production data and just put it into your environment. So what are the advantages of this? Obviously, the data is production data, so the quality is going to be very high. It's going to behave exactly as production, mainly because it's production. So you're gonna cover many of the cases that actually happen in production. But this is a huge risk to put production data in your testing environment because many times testing environments are not as secure as production, and the chances of data breaches are high, and you could get fined, and a big fine. You could lose a lot of clients just because of a data breach. And also, production is usually huge, so it's not going to be easy for you to process it. And if every week or every day, every night in your daily process, you have to get all the production data and put it into your testing environment, that's going to take hours. Every time you run a test, it's going to take a long time. So you want a way to handle that amount of data. So the most typical way of handling these two problems is obfuscating and getting a subset of production data and obfuscating it. Okay, so let's talk about what this means. First of all, what does it mean subsetting production data? I'm going to come back to this slide in a second, but let's talk about the subsetting. So for example, let's imagine this situation where you have this simple database with just three tables, table 0, table 1, and table 2. And as you can see here, they have very, very simple example where you have three primary keys and some foreign keys. So in this case, this foreign key corresponds refers to this primary key, PK1, and FQ10 refers to PK0. If you just get the 10% of this data, so in this case, there's only 5 samples to each table. So if you randomly undersample this data and you just get one sample, for example, as we did here, you can see that the referential integrity is broken. So, for example, table 2 has this foreign key 2 that doesn't have any value in table 1. So you can see that referential integrity is completely broken here. So this table, every time you query anything into this database, it will just break everything. So what is subsetting? Subsetting is about doing this, but intelligently. So for example, in this case, instead of just getting some random samples, we would get a sample that is in all these tables. So for example, we could get this first primary key 0, but then in the table number 1, we would need to go to the foreign key that represents this sample, and similarly to table 2. All right, and in this case, you can see that referential integrity in this case is kept. Second part, we discussed about data obfuscation. So what is data obfuscation? Data obfuscation is is the most traditional techniques in order to get some privacy in your data. So you would get your data and you would apply transformation to it in order to so that the sensitive information is not there anymore, or at least is not that obvious. So in this case, for example, we have one table that has 6 columns, 5 of them have some sensitive information. For example, name, email, age, income, and social security number. We applied some transformations to these tables. For example, the name and the email, we just generated some random emails and names. For the name, we used a fake name generator, and for the email, we used a random regular expression generator. So given a regular expression, it will just generate some values. For the age, we use k-anonymity. That this means making sure that normalizing it and putting into buckets. And for the income, the same. And then for the social security number, we used masking. So the first 8 numbers, we just mask them out. Now, what is the problem with these traditional techniques? There are some cases where these techniques have not worked well. They failed. So, for example, let's look at this Elton Dusk, this random person that we don't know anything about this. We just know about this person that he's 43 years old. Let's say for some reason you know that information. If you get access to the obfuscated table and you look at the age, you'll see that there's only one person in this age bucket. And then you would instantly know that income of that person, at least not exactly, but around some data, you will know a little bit of information about social security number, etc. So this is a very simple example, but there are some cases where traditional obfuscation techniques fail drastically. Like there's a very interesting case that happened, I think 15 years ago already with Netflix. You've probably heard of it already, where Netflix got all the databases of their users, all the the stars and ratings of the users, and they obfuscated that. They added some noise and they published that. Some people, what they did is, hey, I'm gonna get this IMDb database that is already free and I have names in there, and I'm gonna correlate those and I'm gonna find some patterns. And they were able to with the patterns, because people obviously would rate the same in Netflix and in IMDb, and they were just able to put names in the Netflix database, and that was quite bad, because they were able to to anonymize de-anonymize all these values. There are other cases, but traditional techniques can be broken with some attacks like this one. This attack, the Netflix attack, is called Linkage Attack, where you link some external information to your obfuscated table. All right, let's go back to this slide. What are the advantages? The data, as there's a one-to-one mapping to production, it behaves almost like production, and it's quite easy to configure. You'll just need to plug in the obfuscator, but at the same time, it will need a lot of human and manual labor. So you would need to go by column by column in many situations and tell, okay, I want you to use this technique for that column, or this other technique for that other column. So although it's quite simple to start working with it, it may require a lot of maintenance. Also, subsetting is not a simple operation, and if you don't do it well, you can break your environment, you can break stuff, and you can get rid of some information that would be quite important. And as I mentioned already, the data leakage is not completely safe. You're not completely safe from privacy leaks, so that's a problem. And the data quality, as you are masking, you are losing information. You are adding some noise, so you are losing information, and you are losing a little bit of quality. Of course, it's not totally the loss of quality, but it may affect your data. Here you have some tools. There are many more tools, but Tonic AI, Delphix, Dateproof, there are some tools that you can use. They're quite nice products that you can just plug into your databases, and you would be able to obfuscate and subset your data. All right. Another technique is mock data generators. So what is a mock data generator? Is when you just, similar to what we did before with names, is when you generate some random values. Without looking too much at the data, you generate some random values for that data. So for example, let's look at Mukaru. That it's a freely available mock data generator. You can find it online at mukaru.com if I'm not wrong. And yeah, you can see, for example, let's create these 6 columns. ID, you choose the first name generator, email address, gender, etc. And you can see here the data that is generated from this configuration. You can see that the data looks quite realistic, but as the generator didn't look at all at the original data, this might be completely disconnected from the original data, so it might be quite different. So for example, in this case, we have gender. Yeah, I'm looking at it and I can only see one female person and all the others are, gender fluid, non-binaries. So yeah, Mukaru are very, very progressive company. And yep, that's all. There are other generators. There's like generate data also similar to Mukaru. And the problem of this is that they have a very low quality of the data. So it can be realistic, but as it doesn't look at the original data, it might break a lot of things, and it may not behave a lot as production. Now, the risk of privacy leakage is very, very low, because obviously the data that we generated is completely fake. And yes, as I showed you before in the slide before, it's really, really easy to use. You just plug in the generator that you want, and you have your data. Another problem is that it's not scalable to databases, or the scalability is complex. Here I added a couple of other tools, this test data generator and the Redgate SQL data generator, that they can actually generate some data for the databases, and they can actually generate some and preserve a little bit of referential integrity. But it's still, it's difficult to scale to big databases and bigger amounts of data. And as mentioned, requires a lot of manual work because you have to select each column that you want. All right. Synthetic data. Synthetic data is a technique that is quite new. It's quite novel. So before looking at the advantages and tools, let's discuss what synthetic data is. So synthetic data is when you have a complex generative model that learns the underlying data distribution and is able to create new data points. So, for example, in this case, it's when you learn the distribution, you have some original data, and then you plug in your system. This system goes back and forth to the data while it's able to learn the distribution, is able to learn statistical measures, is able to learn all the information that is capable of from the data, and then it generates new data. This new data that it generates is synthetic, is not real, so it's not in the original data, so it's free from privacy. And if the generator is good, the quality of it can be really, really good. So as I was saying, the data quality is typically the best. I'm writing typically the best here because it depends a lot on the provider of synthetic data. So you have to be careful when you're choosing the provider to get the best one, because there are some of them. Obviously, there are a lot of projects that are working on this, so not all of them are going to have the same quality. Now, the privacy leakage is very low, the risk, because the data, as I mentioned, is synthetic. It's fake. It's not your users the data doesn't belong to your users, but it's just new data that just behaves like the original data, but it's not actually original data. But it's important to highlight that the IP and some aggregate measures might still be present. So as your synthetic data behaves like production data, you could have, if you're not careful, you could, for example, generate your transactions, and the total amount might be the same as in the original data. So it's a different type of problem that you still need to take care. And once the model learns the data, it's quite easy to sample large amounts of data, so it's highly scalable, and you can configure some parameters in order to get very personalizable results. Disadvantages. So referential integrity, we talked about referential integrity. It can be challenging to preserve, because as at some point you may be generating thousands of tables at once, it's very important that your generator is able to understand the complex relationships. So it might be tricky to understand what's happening. It might be tricky to do. And this process of generating and learning the data, it's quite complex. So for me, I've been many years studying this, and still it's complex to understand. So it's not a tool that you're just instantly understand what is happening. It's quite complex to understand. That's why, some processes can be difficult to understand what's happening. Another problem is about mappings and external references. So, for example, if you have a column that refers to an external database, if you don't tell that to your generator, he might understand that that's a numerical column, for example, and it will generate it in one way that it will not be related to the external, and you may lose that reference if you don't add that information to your generator. And here you have some tools. Synthesized is one of them. SDP, Synthe, Gretel AI. So let me talk about some of them. By the way, in order to understand properly what synthetic data is, so I'm talking about these tools that we have seen are about structured data. So structured data refers to tables mainly, maybe JSON files in some situations. But these are three examples of synthetic data for non-structured data. So, for example, here at the top you can see this GIF about a person faking being Vladimir Putin, and obviously the quality is actually quite good. If you just see this image, you would be confused about if it's real or not. Or even GPT-3. I'm sure you have all heard about GPT-3 and OpenAI software, which is it's a very very powerful natural language generator. And there's a letter that the GPT-3 wrote about himself or itself. You can see that it's quite crazy how it writes. And there's an example of here how we can simulate an environment for a driverless car. You wouldn't put a car into the real world without testing it. So this is an example of how you can use your synthetic data to test your models and make sure that your driverless car won't behave weirdly. All right, I talked about data quality. So here you can see some statistics and some measures about this our engine at Synthesized. You can see some results. So here at the left here you can see the Kendall-Tau correlation. So this is a matrix that corresponds that these are some metrics between the correlation of each pair of columns. So for example, this value here corresponds to the correlation between column B and column A. You can see that it's in the original data is 0.45 and the synthetic data is again 0.45. And you can see that overall the correlations were kept quite nicely. Same here in the synthetic and original data, they are very, very similar. And if we look at the marginal distributions, also they are kept really, really closely. So these are all categorical distributions, and these are all continuous distributions. You can see that you can mix some types. You can have different data types, and still it's able the synthetic data generator, if it's powerful enough, it's able to generate very, very high quality data. All right, let's talk about some tools. First of all, I'm going to talk about a couple of open source tools. So Cynthia, this is a patient generator. So medical and healthcare data is they have a lot of problems with privacy, obviously, because they have very, very sensitive data. And what this project does, it generates some fake data about some patients. That is obviously it's very healthcare oriented, so you won't be able to just plug it into any application, but it's very powerful for the healthcare world. And it's open source, it has a community, so you could work with it if you are working some healthcare application. And secondly, there's this synthetic data vault that is a MIT project. It has multiple data generators. It learns the data with some quite powerful techniques like GANs and other deep learning techniques. It's open source, so there's a community that you can talk to them. But the only problem is that it's a nice introduction. It's a nice way to get into the synthetic data world in understanding how these processors work. But as it's an open source tool, it has some limitations still, and yeah, it's under development. But I think it has some scalability problems for what we have seen, and yeah, some other commercial options, synthetic generators, can be better. And yeah, what about mixing all these techniques that we discussed before? So you have some situations where you could mix all these techniques. So you could say, okay, this table is very important for me, so I want to preserve it with high quality. Okay, you would maybe generate some synthetic data for that. This other table for me, it has some data that is not relevant at all, but I just want to put it with some mock generator. So you would just put some mock generated that. So at the end, sometimes it's good to just mix all the techniques and have a good taste and have a good way of putting the best into the best all the time. What is the problem? Maintenance can become quite hard because you have to choose. Although, yeah, we can. We're trying also at Synthesize to make this automatically so that the maintenance becomes very very low, and at the same time, it may require some fine tuning and configuration, because if you don't do it properly, you can end up with the worst for each one. And yeah, I also, just to end this topic, I wanted to mention Synthesize. So the core technology at Synthesize is a deep learning model that it's state of the art techniques, and it's able to generate very very high quality data. And but we combine that with some data sources. Many, you can configure that into data sources, generate data projects, put the collaboration aspect that I mentioned at the beginning into it. Has a lot of flexible data types generation, etc. All right, a summary of what I've talked in this part of the talk. You can see here, yeah, production data, as we discussed, it has very high quality and probably a lot of test coverage, but the risk of leakage and time to production, it's going to be high. Pretty high time to production because of compliance problems. You're going to take quite a while to get that data. Obfuscated subsetting, it's kind of halfway there. It's solves some problems of using production data, as I mentioned, but it's kind of halfway. So the quality is not as good as it could be. Testing coverage could be lost. Time to production, it's not perfect. So, and also it's not scalable, and it's difficult because to maintain. Mock data, another one. It's quite fast. It's quite the risk of privacy leakage is very very low, but at the same time, the data quality and testing coverage, it may be quite low. So these are quite bad. And yeah, for me, as I may be a bit biased because I work at Synthesized, but for me, synthetic data is the future. Is because it's able to, modern and good generators are able to generate data that really really looks and tastes and feels and smells like production data, but they are not actually, it's not actually production data. So you can get out of those privacy problems, and you can get some scalability. Of course, yeah, scalability sometimes may be a bit problematic when, as I was talking about, referential integrity and bigger, huge databases. But yeah, I think, in my opinion, is going to be the future. All right, we discussed some applications to make sure. One second, let me get a glass of water. Okay, we discussed some applications to get data. You have some production database and you want to populate your testing environment, your development environment, etc. Now, how do you make sure that that data that you added to your environment is the best for your application? So I want to talk about data coverage here. So what is data coverage? We want to understand how many of the test cases and site cases are covered by the data, and understand that number, give it a number, give it a value, and then be able to make sure that the data that you have is the best one for your application. Now, this is a developer. There's a conference, and there's a lot of developers here, so I'm sure a lot of people know this code coverage concept. Is quite a broad one. These are a couple of screenshots from Sonar Cloud. So code coverage is you just run some unit tests, you write some unit tests, integration tests, all your tests, and then the code coverage is able to automatically understand which lines of code are run and which ones are not by your unit test. In this case, you have an overall coverage of 79%, which is quite good, but it could be improved. This is probably should be bigger. But this is a nice way to get introduced to the coverage understanding. So let's look at an example. For example, here we have a function that computes a statistical distance between two columns. And you can see here at the left some red and green lines that tell you how much of these lines are covered by your unit test. So you can see, for example, that when the mode is auto, yeah, these two lines are covered. But when this mode is in distance, in this distance metric, in this array, well, this dictionary, this is only partially covered. This is probably due to testing cases only having few of the values here. Or also you can see that this value error is not checked. We're not checking that this is actually being raised, or we're not checking about this p-value. So yeah, this is a concept that I'm sure you're familiar, but it's good because it's a good introduction to data coverage. Now let's go from code coverage to data coverage. Okay. At the beginning, when we're looking at the infrastructure, we looked at a schema like this. When you have a data warehouse and you have an application, or you have some data consumer, and then you have some data going from the data warehouse to the application. But it's difficult to understand how to do the reverse feedback, right? So if you're the application, how do you go to the data and tell to the data, hey, you're good, you're bad, you're what I need, you're not what I need? There's no connection there. It's kind of isolated. It's only like a one direction. So we want to look at something that the application actually sends to the warehouse, to the data warehouse, and we can look at the application logs. So we know that the application is interacting with the warehouse, so we can understand how this application is interacting. We can look at the queries. We can look at the calls, how the application is calling the data warehouse, and then maybe we'll be able to understand how this data looks like and how this data must look like. So what we want to do now, as we did with code coverage, that we split the code into different areas and we looked at which one were run and which one were not by the unit tests, we want to do the same with data. So we have with some database, and by looking at these application logs, we want to divide this data into different rules, and we want to make sure if the data covers all these rules. So for example, here at the left, you can see a schematic map that tries to explain this idea. So imagine you have a two-dimensional space, and you're splitting each of these rules splits the world into the data domain into different buckets, and then you have to make sure that there's at least one data point in each of these buckets. Okay, as you can see in this case, this area would be covered by the data, but these two data buckets won't be covered. And yeah, we've been working on this at Synthesize. We've been working on trying to split this data and looking at the logs. And I just wanted to show you some examples of a client that we worked with, just for you to see that although these are a client that they thought they didn't understand how much coverage they had. They just knew that they have some application that was interacting with the data, but they were not sure what was happening. They were just testing everything very manually. So we did this approach that I just described with them, and these are the results of what they were having. And actually, you can see that they didn't even get to the 50% of the coverage. So it's actually quite bad. And in this case, we were able to segment the space into 175 buckets, and that's the number of going back to the previous slide. These are the number of total rules or total buckets here in the left, total spaces and divisions. So yeah, you can see that even they expected it to be quite quite high, it was actually quite bad. All right, let's look at some tools that you can use in order to look at what we described here. So Great Expectations. I think Great Expectation is a great open source tool that it has a great community and it's very documented. So it's really nice to use. What is the Great Expectations? It's the name. It's very self-explanatory. What Great Expectations does, it allows you to set expectations to your data. So, for example, here you can see some examples. Expect column values to not be null. Okay, so you can set some expectations like this. Expect this column to be not unique. All right. So if you go back to what I was telling before, if you are able to extract these rules, then you could plug in Great Expectations, and then you would be able to make sure that your data coverage is as good as you want it. So, for example, at least for 85% of the time, you got this data that fills these rules that you are looking for. All right, this is a nice tool that would be that you would be able to plug in. Another tool that I wanted to mention is dbt. dbt is usually used as a transformation tool. So you would plug it into your database and it will transform your data into some data that looks slightly different. But in this case, I wanted to talk about them for more about data validation side of it. So you can do similar things to Great Expectations, like you can see here, for example, assert payment amount is positive. So you can make sure you can code up a little script that looks at your data and makes sure that all the payment amount is positive. That's what you would expect from the rules. Or quite similar, make sure that this event ID is a unique. So you could plug dbt after you understand the rules, you could plug your dbt there, and then you would be able to validate that your data looks as you want to. Also, something really nice is that you can easily integrate it into your CI process, and make sure that every time you commit anything, it's passed and your data looks like exactly as you want it to look. Okay. These two tools are good once you have the rules. You can plug them in and make sure that the data that you have follows that rules. Now, how do you extract these rules? There's a lot of exploration about these data logs and application logs. So, for example, here you can see some open source projects that they parse SQL queries. They parse some SQL and logs between databases and the application. But yeah, it's everything open source, and there's like a lot of projects. But this is the first step that you would need. You get the query logs, you parse them into some rules, and then you would get dbt or Great Expectations, and you would transform these rules into expectations, and then you would validate your data under those expectations. All right, finally, what we were doing before is looking if your data follows your expectations. Now, if it doesn't follow your expectations, what can you do about that? Can you generate some data in order to fulfill those expectations? And the answer, is in this case, yes. So, for example, GenRocket, they have a nice tool that you can generate data from rules, and you can generate data that, for example, in this case, you can say you have these 4 rules, and each one of these rules have some different bucket of amount balance, and depending on where you are in your balance, you would obtain a platinum account, you would obtain a bronze account, etc. So yeah, from GenRocket, you can give all these segments, and you can tell him to generate data based on this segment. So you can see here the output for these rules here at the right. You can see that it was able to generate the reward level for all these different balance and for these account numbers. All right, and getting at the end, I also wanted to mention synthesize, because we're doing something very similar. We're trying to put all these concepts that I've talked together, and we're trying to do so. You saw this schema before, where we have some database. We split the database into some segments, into some rules. We put the data through these rules, and we looked at how many of these segments were covered by the data. Now, what we want to add is we want to add an engine that is able to, given the data and these rules that were analyzed, we want to generate some more data that actually covers all these cases, all these side cases, and you're able to improve the data coverage to the end. And also, we want to make this as easy as possible to just plug it in and it's done. And yeah, just wanted to share same table as I shared before with some results. You can see that quite easily we can obtain quite a high coverage. And also, what is quite important is that at the beginning we had like 200 samples, and in this case, you can also not only obtain better coverage, but also reduce the number of samples. So it's not just about improving the coverage, but also about reducing the size of your database. That, as you remember at the beginning, we discussed that production data could be huge, and you probably want to shrink it and make it small. So we also want to do that at the same time. And yeah, we just to mention very quickly to finish the talk, we have this query analyzer online for free. This tool that it's available online. It's the link is up here. You can just click it and play with it. And yeah, we would love to see your feedback. And yeah, if there's anything else, please feel free to contact me or anyone in our team. But yeah, that's all I wanted to talk about here. I'm going to leave you some resources about that. It's about me or some of my colleagues talking about some of the topics that I mentioned in this talk, like why traditional techniques are not actually that robust into privacy attacks. This testing, it's about getting some data into your environments, and there's a couple of podcasts talking about topics similar to what we're discussing. And that's all on my side. I hope you liked it. Here you have again my contact details. You have my LinkedIn account. Please contact me, ask me for anything if there's any doubt. And yeah, hope you like the talk.
Yes, we are. Thank you, Don. Thanks. It was fantastic. Even I knew something something different I didn't expect from the talk. All right.
Nice.
I believe we can talk a little bit about how do you use the parsed SQL queries. Like you mentioned that you parse them and somehow feed into this magical box, which will guide you which kind of segments or parts of that covered or not with the data you currently have. And how can you bring some light how it's happened and what's kind of like branches or segments whatever from SQL you use?
Yeah, so this can be extracted. This is quite it's a difficult concept to explain, and there's quite a bit of things happening on, and I don't want to get too much into the technicalities. But yeah, what you need to do is you have some data, and you need to understand how the application and which segments, how the application looks at the data. So for example, you would have an application that queries some data, and then it transforms the data into different parts, and then that data you would understand it as these segments. I would like to get into more detail, but I think this is a little bit private right now, so we're
Okay.
gonna make more information public about this.
Mm-hmm.
But yeah, it's a bit of an IP. So
All right. So you're saying that you would need to have sort of like application logs or some SQL dumps, how the application uses the data, meaning that you've got to run the app and wait for some time while it's like regularly used by some users of the platform, and then use that all these queries, parse them somehow, get this kind of rules and match them to the data you've got on the database. But before that, you have to synthesize the data, or you have to somehow randomize the data or whatever it is. So you can use these techniques, right?
Yeah. Yeah. So for example, we can think of it as you have a database with, I'm just making this up. So you have a database with a credit application process, for example, right?
Right.
So then you would have one application that generates some offers for clients that are over 60 years old and have income over 20K, something like that, right? So for those people, you would generate one product, and then you would get another type of client who's between 20 and 30 years old, and they have a certain income, and then you would generate another offer for them. So in this case, you see that the application queried the data in two different ways in order to create two different offers. So these would be your two different segments that you would have in this example.
Okay. Okay. Yeah, and that means that we will have to support different kind of SQL or any other languages which are used in the databases which we support, right? So we need to support all the adapters and all the ways how we parse this. All
Yeah,
right.
yeah, exactly. These application logs, they can be. There's a lot of ways that this interaction can happen between the application and the data. So yeah, this can be in many different languages, and each language would have its different parser and its different segmentation.
Okay. Okay, gotcha. And while developing this solution, maybe you recognize or remember some of the top problem you've seen while doing all that stuff, or while inventing this approach. Maybe I don't know, you faced with some particular ones, and there is one thing you remember quite well because it was so annoying for you. Maybe you can highlight that.
Yeah, I think one of the biggest problems that I faced when working with databases is that although there's a lot of standards and things and ways that databases have to be and or they should be, they're not strict. So people can build databases in a very flexible ways and very different ways. And this can end up in having some very, very complex referential integrity constraints and some tables that depend in some others in very different and complicated ways. And I think that has been one of the biggest challenges when developing these machines that automatically go into the database, they explore it, and then they extract all this information. So yeah, there's a lot of information there that is very, very complex, and I think extracting this information is very challenging, but it's a very interesting topic also.
Yeah, by the way, for as for the referential integrity and following primary keys, to make the synthesization or to make the insertion of this data, I mean, of course, we can synthesize data, but we have to inject that to some particular database or some particular staging environment where we have our test application or application for the development purposes or for analytical purposes, whatever they are. We have to inject the data, so it's not just getting the data to some, for example, raw format and making this synthesized process. It's also about duplicating the structure of the database, right? So you have to replicate all the indexes, things like that. And it sounds to me
Yep.
like quite complicated problem, isn't it?
Yeah, it's actually that's a very good point. It's just looking at the structure of the database, and even if you don't look at the data, just looking at the structure and putting it and replicating it in some other environment, that's not a trivial exercise to do. It can get very complex, and I think also another problem is that even if you fully understand the structure of your database, then there's going to be some hidden information that just some users know, and but it's not actually configured there. So you have to somehow look at the data, look at the structure, and be able to extract that.
Hmm.
So yeah, it's a challenging problem. Yeah.
So to make all the things work well for the users of such platforms or such tools, you need to support different things. You need to support different queries, languages, I mean, as well. You need to support different databases and to be able to replicate those kind of on the fly, because that's how people want to use this tooling. I don't believe that someone wants to, configure everything by themselves, or replicate Postgres or Oracle or whatever databases they've got, and then inject the data afterwards. And yeah, so it looks like a lot of things to be done or to be developed in such platforms. Okay.
Yeah.
Uh,
Yeah. It's very complex, and there are a lot of different infrastructures that you can use this, right? There's you could have like some SQL databases, but then you could have some non-SQL databases that they would
yeah.
behave differently. So the queries are not, they look quite differently, because although Oracle, Postgres, all these databases, they have a lot of things in common, then you can get out of it and get to some graph databases and some other complex things that make the problem even harder. Yeah.
Yeah, that's what I wanted to ask about the NoSQL solution. As far as I understood from your talk, you've been talking more about some relational databases, but we haven't yet covered NoSQL, and as you mentioned, some um, graph-based solution. It's kind of more harder problem, or it's something that you haven't discovered yet, or what's the state of the art here?
I think it's similar problem. It's it's important to build these solutions in a very modular way. So if the queries or the application logging is different, then you can just plug in another parser and then transform it and use again some of the tool into different one. But yeah, it's true that things get a bit quite they get quite complicated when you get
Hmm.
into these databases, because the data is less structured and it's more difficult to understand all these structural complexities. So yeah, we're right now focusing in relational databases, but
Hmm.
it's if we want to investigate also into more non-relational databases, and yeah, like NoSQL or Graph,
Hmm.
Neo4j or anything. Yeah, that's going to be very challenging future.
Sounds to me a lot of work. Okay. All right. And I think there is another one around the approach, how your algorithm, I mean, the machine learning algorithm works with the data. How do you recognize the values? So you were saying that you want to keep the historical data, or you want to keep the data kind of consistent and smell like the original one. But is there any like way how you can describe how it basically it works, or in just in the basic terms, how do you recognize some patterns, or what's the logic behind it?
Uh, yeah, the logic is actually quite complex. I think it would take like a whole new talk to explain the whole the whole generator,
All right.
because it's about, yeah, there's some state of the art like machine learning techniques that they are able to go iteratively through the data. They load some data, they look at it, they generate some data, and then they compare the data that they generated to the original data. And yeah, there's some loss function that computes making sure that the data looks as similar as possible to the original data. And then the algorithm goes iteratively through the data, looking, generating, etc., until it converges and it gets to a point where the data it looks very realistic.
All right.
And
Yeah.
yeah, you have to, obviously, the to handle different data types, that's a modeling decision. So if you have like categorical, continuous, or whatever type of data, then you would just model it in one way or another.
Hmm.
But yeah, at the end, all the data types can be modeled in one way or another. So So yeah, at
All
the end,
right.
it's just adding some complexity, and you would be able to generate very data that looks very similar to original data.
Okay, yeah, sounds really cool, and want to hear that talk in the future from you, Ton. By the way,
Perfect.
yeah, I think we are kind of out of time right now, and I believe you guys some time ago open source some library called Fairlands, and for those who listened to us till the end, you know about that. I guess you can find it. It's Fairlands at GitHub. You can find it and play with it if you're interested in making sure your data is fair and not biased. You can use this open source solution developed and cooked by the synthesized folks. And thank you very much for your talk, Ton. It was a pleasure talking with you afterwards. In case you guys have any questions, please go to the discussion where we will be with Ton trying to answer all of those. And I guess that's about it. Thanks, Ton. See you around.
Thanks, Seba. And yeah, if you have any other questions, I'm just gonna stay around here for a while in order to yeah have a proper discussion about any topic that was not clear.
All right. Thanks and see you around.
Thanks, Seba.